Hey there, my psych kiddos. Here we are. Welcome to Chapter 3. Chapter 3 is about the biological foundations of behavior. So we talk about the neuros. Here's where we introduce neuroscience, which is the body's electrical or electrochemical communication circuitry. So it talks by neurotransmitters. Neurotransmitters carry information from one neuron to the other and helps the body do what it's supposed to do. Now they do so by creating different chemicals, right? So the first chemical the textbook talks about is acetylcholine. It's the book abbreviates it as ACH. ACH helps with muscle actions, learning, and memory. Now there are certain things that can affect the ACH, one of which is black widow venom. If you've ever been bitten by a black widow, it will cause your ACH levels to rise. If you've ever had Botox causes the ACH levels to decrease. And if you have Alzheimer's disease, that can be discovered by, or can lead to, or the lowering of ACH levels can be caused by Alzheimer's disease. Now, GABA is another neurotransmitter, and if you have anxiety, causes your GABA levels to be lowered, right? So different anti-anxiety or different anti-depression medicines will help raise that GABA level. Other neurotransmitters are glutamate, which helps with excitement, learning, and it's also involved in psychological disorders. So if, depending on what psychological disorder you have or somebody has, the levels of glutamate will differ somewhat. And then of course we've got norepinephrine. Norepinephrine is elevated during stress and mania. Norepinephrine is lowered during depression. In conjunction, norepinephrine in conjunction with acetylcholine can help regulate your sleep patterns. Another neurotransmitter is called dopamine. Dopamine helps with voluntary movement. It also helps with your reward anticipation. Dopamine it helps with the anticipation and excitement. One of the problems with the overusage of technology for younger children is that these dopamine levels are in a continuous state of upheaval. The dopamine is constantly flowing, so it's that constant reward, that instant gratification. And so what happens is the body and the brain becomes dependent on this dopamine, so they have to have something to stimulate that all the time. If not, then there's the I'm bored, right? But then you've got stimulant drugs. There are certain drugs that are stimulants that will actually activate those dopamine receptors. But if you have a disease like Parkinson's disease will cause the dopamine levels to drop. However, if you've got schizophrenia, those dopamine levels are elevated. Serotonin helps with sleep. Serotonin is made naturally, but you can also help that serotonin level by what they call using SSRIs, which is serotonin reuptake inhibitors, selective serotonin reuptake inhibitors, which helps the serotonin kind of bounce back, because if you're depressed, if you suffer from depression, then those serotonin levels are decreased, which is one of the reasons why people with depression sleep so much, is because that serotonin level has bottomed out. So the introduction of a drug like Prozac will increase the levels of serotonin, and therefore making the sleep regulation a little, it'll help with that sleep regulation. Then of course we've got endorphins. They're natural opiates. Endorphins are, you get the endorphins going, by excitement. It's a natural opiate. It's a natural painkiller, and sometimes that excitement's not necessarily positive. Endorphins are get going if you've ever been in a horrible car accident. And those endorphins, or that like adrenaline rush, can keep the body from feeling pain. Now, once the body slows down and that adrenaline starts to decrease, and now those endorphins start to decrease, then you're going to start to feel that pain. You know, it's one of those things where you don't really realize you're hurt until you notice it. And then that's when everything starts to hurt, because at that point the brain is slowing down and you're beginning to realize that, oh my goodness, something is not quite right. And then the body also creates oxytocin, which is both a hormone as well as a neurotransmitter. It's related to the onset of lactation in new moms, so it helps with the uptake, or the increase in oxytocin will help mothers lactate. It's also related to attachment and emotional bonds. So if you're mothers or fathers who are more emotionally attached to their children, will have this increase in oxytocin that is created by the body. And understand that any drug you take can interfere with any and all neurotransmitters. The drugs can either increase the natural causes of the neurotransmitters, or it can decrease it. So depending on what drug you're using or what substance you're using will affect those neurotransmitters, and then affect how you work, or how the brain reacts. Now, the brain, if you look at a picture of the brain, and the book has got a really good picture of the brain, but you have what's called the corpus callosum, which is a bridge of fibers between the two hemispheres of the brain, because you've got your right brain and then you've got your left brain, and each side of the brain is specifically geared to do certain different things. However, what researchers found is if you split the corpus callosum, then the sides of the brain won't talk to each other, and therefore you're going to miss some information. The only reason the corpus callosum would have been severed is an extreme epileptic during severe epileptic seizures. Because what happens is, in a seizure, it's almost like the brain starts to misfire, and then the misfiring from one side goes across the corpus callosum to the other side, and thus just kind of short circuits everything out on both sides. So the split brain research is, if there's several different ways to do it, but what they've done is, once they've severed the corpus callosum, you can, depending on which side of the body, if you see something, and if you can see a color, and then on the other side, if you cover up the other eye, you'd be able to tell if there was a green 4. One side of the body you would be able to say the word green, and on the other side of the body you would be able to say the word 4, even though you see the green 4, but one side of the brain registers green and the other side of the brain registers 4, but they don't combine together. So depending on which side of your body is being exposed to that stimulus will depend on what you can then relate. And then of course the right brain, left brain is across. So anything that you see with your left eye is being processed by your right brain. However, anything you see with your right eye is being processed by the left brain. So it actually goes across. So I used to tell my cousin, who is left-handed, that no matter what happened, she would always know that she's in her right mind, right? So, but the large bundle of axons, which are that fibrous tissue that connects the two parts of the two hemispheres, and allows each side of the brain to talk to itself. Okay. Each hemisphere has its own specific function. Okay, so your left hemisphere is your verbal processing, your speech, and your grammar. It's also, and then the right hemisphere, is your spatial perception or your spatial reasoning. It's also your visual recognition. It also controls your emotion. So if there's any part of the brain, if you've known anybody that's ever had a stroke, depending on what part of the brain or what side of the brain has been damaged, will depend on what function that they lose. So, anybody that's ever had any brain damage, not everybody that has brain damage has the same reaction. So depending on what side of the brain or what part of the brain is affected will depend on what brain damage is. Now, just because somebody has brain damage doesn't mean that they cannot or will not recover from it. Recovery from brain damage depends on a lot of different things. One of them is the age of the individual. If the individual is younger, they're more apt to recover from that brain damage. Because what happens is the body in and of itself is very good about overcompensating for anything that's missing. So if you're lacking in visual stimulation, then your hearing will be increased. If you don't have a sense of smell, then maybe your sense of sight is increased. It just depends on what is needed and what your body will kind of in a sense will reprogram itself to do. It also depends on the extent of the damage. The more damage, the more damage, the less likely there is to be a full recovery. But the repairing of the brain damage is what the overcompensation is what they call substitution of functioning. So, different things will pop up and the brain will create different ways to deal with things. Now from here we go into the genetic expression of the genes in the environment. You've got what they call, there's two different types of genetic expression, which is one is your genotype and two is your phenotype. Your genotype is your genetic heritage. That's what you can't see. That's just what your DNA is, what your genetic code is, versus the phenotype, which is what you can see. It's a physical characteristic, it's your psychological characteristics, your eye color, your intellectual capacity, things of that nature, what you can see, your height, your weight, things along that line. Now, as we mature and as we grow, things are going to change. How our body processes information, how our body deals with stress. So one of the things that we as far as stress in the brain goes, any type of stress that happens, the brain has the ability to cope. Sometimes we cope better in some situations than others, and then some people cope better in stressful situations than others. Excuse me. So, but depending on a lot of different variables will depend on how well a person can develop these coping mechanisms. All right, so stressors are anything that causes stress. And then stress, of course, is the reaction to that stress. And stress can be elevated blood pressure. It can be what we call it, my daughter, we call it meltdowns, where it's just like her brain just is like there's too much information and it's just an overflow of information. And it's like her brain just short circuits and she just kind of spazzes out. So some people don't deal with stress very well, and other people deal with stress very well. Some people will get energized by stress. People that work well under pressure. People that procrastinate, which I don't recommend, by the way. But some people say, "Oh, procrastination. That last minute, that adrenaline rush or that endorphin rush helps me get through." But what you're doing is you're creating a scenario where the only thing you're going to be able to do over time is to react. Unless you have that stress, you're not going to be able to react. So that stress can sometimes hamper everything because it's just like the endorphins and the dopamine. Without them, the body cannot process information or cannot do things like it's supposed to. All right. It's a heavy topic. It's a heavy chapter, but that's kind of a very, very quick, down and dirty part of the brain chapter. The textbook goes obviously into a lot more detail, but I'm not gonna bore you with that. You guys are awesome enough to be able to handle all that on your own. So questions will be posted to Canvas. If you need anything, again, don't hesitate to email. I'll answer your emails as quickly as I can. All right. In the meantime, you guys stay safe, stay well, and we'll see you later. Bye.